Hey guys, welcome back to your second tutorial in network security and cryptography. In this video, we'll go over some symmetric ciphers, more importantly the simple Caesar cipher and the monoalphabetic cipher. And we'll just have a quick recap of what we've learned so far. So to move any further guys, we just need to quickly recap on our definitions. So one of the first definitions that we're going to use is plaintext. The second is ciphertext. And lastly, it's 2 in 1. You've got your encryption and your decryption process. So in recapping again, a very, very simple symmetric cipher model. Let's say we've got Mike here, we've got Mark over here. So Mike wants to send the message hi. He does so by putting it into an encryption process or an encryption algorithm, whatever he chooses. So he encrypts that with a key. Now this key is shared by and shared only by Mike and Mark. And without the key, cracking this would be quite difficult. So Mike encrypts the message hi with the key that is shared between Mike and Mark through the encryption process. What comes out the end is what's called the ciphertext. Now the ciphertext travels through whatever transmission medium, right, until we get to the decryption process of what Mark is going to use. So he uses the key that is shared only again between Mike and Mark, and he decrypts it, and he gets hi. So as previously discussed in the previous tutorial, within the realm of symmetric ciphers, there are substitution techniques and there are also transposition techniques. So substitution ciphers replace and transposition ciphers, they mix, okay? So I'm just going to list a few ciphers within each category. So first off, we have substitution, and then we also have transposition. Okay, so the first few in the substitution techniques category is the Caesar cipher. There's also the Monoalphabetic cipher, cannot spell. There's also things like the Playfair, the Hill cipher, and there is much more. And again, so substitution, substitution replaces. Okay, so these ciphers, they actually replace an element in your plaintext with something completely different. It could be letters, numbers, symbols. It could be anything. So over in the transposition the transposition techniques category, we have the rail fence, and we also have the row transposition. So first off, we'll go over some substitution techniques. And the first one that I want to show you is the Caesar cipher. So this cipher replaces plaintext letters or numbers with other letters or numbers, and I'll show you how. So the Caesar cipher, so I'll just write it down, Caesar cipher, is one of the earliest known and simplest ciphers. It works by sharing a secret key with you and your friend and shifting the letters in the alphabet by the value of the key shared. Then to decrypt, you move backwards the value of the secret key to uncover the plaintext. So for example, let's say that you and your friend share a secret key of 3 and you wanted to encrypt the word YouTube. You can do so by moving each individual element in your plaintext, so the U or the O, the Y or the O or the U, 3 shifts in the alphabet. So Y actually becomes B. So it works by Y, Z, A, B. So it shifts 1, 2, and 3. So Y becomes B. So this actually turns out to be BRX, W, XEW. So now, to decrypt, all you do is work backwards. Okay, so you start with B, so for example with B, and you know that the key is 3. Moving backwards 3 spaces, you get Y. And you continue on until you get the plain text, which in this case is YouTube. Now, let's talk about the monoalphabetic cipher. So for the monoalphabetic cipher, each letter, right, let's say you're given the normal alphabet, your key is the cipher alphabet, which is what you see below in purple. So for example, if you were to, if the first letter in your plain text was a H, the next letter in your ciphertext would be a G. So let's encrypt the word YouTube again. So the first one on YouTube, we see Y. We go up to the end here, we find Y. We find that the first letter in our plain text, is now P. So we do the same thing with O. We look at O, becomes Z. We look at U. U becomes W. We look at T. So T stays the same. U becomes W again. B becomes M, and E becomes J. So this here is now our ciphertext. And if we wanted to decrypt this, all we do is we'd send this key here to our friend, and they would be able to decrypt this. So that is the monoalphabetic cipher. So that wraps up today's second tutorial, guys. Make sure to stick around if you would like to learn how to encrypt and decrypt data with the Hill cipher, the Playfair cipher, and the Wegener cipher.